Yeah, when you bend the particle, you can tell what it's doing.
Yeah. So if you look here, this is, if you were a proton, you'd be flying in this direction, going into the board or coming out from the other direction. Okay? And then you collide in the centre, and then particles spray out in all directions.
How do you make sure that you collide in the center?
Ah, it's magic. just it is. So before that, you have other magnets that steer the beams, as Paul was saying upstairs, so you can direct them where you want with amazing precision. So sort of a few microns. So your hair is about 100 microns wide, so a tenth of a millimetre. But we can steer them much, much better than that over huge distances. We have to be able to.
We don't have one proton. You have a bunch, billions of protons in another bunch. And very often the bunches will pass straight through each other and none of the protons will collide. But they pass each other billions of times per second that you end up getting billions of collisions per second.
Kind of like that, yeah. So, when they collide in here, you spray off in all directions, and you've got different layers. So there's an inner layer there, there's this blue layer there, green. Let's look at the simple side. There's this layer there, green layer there, orange layer there. This grey layer is the magnet. And our magnet is just one big coil of wire, essentially. And then you've got these other layers that are in silver here. The red is solid steel. So this is what makes up most of the weight of CMS. And as Paul said, the magnet bends some of the particles. So if we take a close-up look at one part, let's take a slice through here. And there are different types of particle that we're interested in. Again, lots of the interesting things like Higgs doesn't travel any distance at all. It turns into something else immediately. And what we look for is the things it's turned into, called stable particles. Things that you've heard of, like the electron, maybe things like neutrons. There's something called a muon, which is a bit like a heavy electron. There's things called photons and so on. All of these particles do different things in the different layers. So for example, an electron, there's this red thing here, so it bends in the magnetic field, and it leaves these little crosses in silicon detectors that are in this inner layer, a bit like the one I showed you upstairs. And where it leaves a signal, you get these little crosses, if you like, and then you join them up like a join the dots puzzle. So you know where it went. And the amount it bends tells you how fast it was travelling. And then it leaves all of its energy, it stops in this green layer. It doesn't get any further. And this is called the electromagnetic calorimeter. This is a bit I'm responsible for now. And if you see a signal, a big signal in this layer, pointing to a track or a trajectory that is in this, you know it's an electron. There's nothing else does that. If you have a big energy deposit in this green part, but no track pointing to it, you know it's this other thing called a photon. So by combining the information from the different layers, you can identify all the different particles and then determine what happened actually in the collision.
What if there's a particle that behaves like some of these particles, but it's something